Okay, I hope I'm audible to all students who are attending this lecture. We intend to start with a new topic within mathematics. This is called as three-dimensional geometry. This is a fresh topic within the mathematics course, three-dimensional geometry. Okay, so the lectures on three-dimensional geometry will also be using some of the important concepts which we have learned in our lectures on vector algebra. Okay, so let's start with lectures on three-dimensional geometry. So the first thing we need to understand, the first concept within three-dimensional geometry is the concept of direction ratios, and direction cosines of a line. Direction ratios and direction cosines of a line. Okay, so let's understand this concept. Although if all students can recall, we have done this concept in our lectures on vector algebra. But we intend to revise this again in our lectures on three-dimensional geometry. Okay, so recall from our lectures on vector algebra. Recall from our lectures on vector algebra that if a directed line capital L passing through the origin makes the angles alpha, beta, and gamma with the x, y, and z axes respectively. So guys, this alpha, beta, and gamma are called the direction angles. Then the cosine of these angles, namely cos alpha, cos beta, and cos gamma are called the direction cosines. They are called the direction cosines of the directed line L. Okay. So all students can recall, if we have a directed line L which is passing through the origin, and this line L is making angles alpha, beta, and gamma with the x, y, and z axis respectively, where alpha, beta, and gamma are called the direction angles. Then the cosine of these angles called cos alpha, cos beta, and cos gamma are called the direction cosines of the directed line L. So if you all can recall from our lectures on vector algebra, we used to denote direction cosines by L, M, and N. So I can say Therefore, the direction cosines of a directed line L, the direction cosines of a directed line L are L, which is cos alpha, M, which is cos beta, and N, which is cos gamma, where alpha, beta, gamma are called the direction angles. So hoping that the students have understood the concept of direction angles and direction cosines. A directed line passing through the origin, making the angles alpha, beta, and gamma with the x, y, and the z axis respectively. These are called direction angles, and the cosine of these angles L, M, and N, which are cos alpha, cos beta, and cos gamma, are called the direction cosines respectively. So hoping that students have understood this, then let's understand what is meant by direction ratios. Okay, so let's understand what is meant by direction ratios. So any three numbers that are proportional, to the direction cosines of a line, any three numbers that are proportional to the direction cosines of a line are called the direction ratios of the line. Okay, so any three numbers which are exactly proportional to the direction cosine which we have just learned, these three numbers which are proportional to direction cosines are called the direction ratios. So we can say that if L, M, and N are the direction cosines, if L, M, and N are the direction cosines, and A, B, C are the direction ratios, of a line, then I can say that A is equal to lambda L, B is equal to lambda M, and C is equal to lambda N for any non-zero lambda belonging to set of all real numbers. So guys, you can clearly see that A, B, and C are called the direction ratios, because these direction ratios are proportional to the direction cosines L, M, and N. So you can see that L, M, and N are the direction cosines, A, B, and C are the direction ratios, and you can see that the direction ratios A, B, and C are proportional to L, M, and N. Okay, so I can also call it like this, that suppose I erase this off and I can say, let A, B, and C be the direction ratios of a line, Let A, B, C be the direction ratios of a line and L, comma, M and N be the direction cosines of the line. Be the direction cosines of the line. Then I can say that I can put it like this, guys. Suppose my L upon A is equal to M upon B is equal to N upon C. Let this be some constant K. Why? Because a few minutes back we just said that the direction ratios are proportional to direction cosine. Now, since the direction ratios are proportional to direction cosines, we can say that L upon A is equal to M upon B is equal to N upon C, and let all these three be equal to some constant K. So I can say therefore L is equal to AK, M is equal to BK, and N is equal to CK. I can write it like this. If L upon A is equal to K, then L will be AK. Similarly, M upon B is equal to K, so M will be BK. N upon C is equal to K, so N will be equal to CK. And all students recall from the lectures on vector algebra. All students recall from the lectures on vector algebra that sum of the square of the direction cosines is exactly equal to 1. Sum of the squares of the direction cosines are equal to 1. That means L square plus M square plus N square is equal to 1. Now what is L square? So I can write, instead of L square, I can write A square K square. Instead of M square, I can write B square K square. Instead of N square, I can write C square K square using this. And this is equal to 1. So I can write K square times A square plus B square plus C square is equal to 1, which implies K square is 1 upon A square plus B square plus C square, which implies K is equal to plus minus 1 upon the square root of A square plus B square plus C square. So now if I put this value of K in these equations, what do I get? So I can write, suppose guys, this is equation star. So putting this value of K, in equation star, what do we get? L is equal to plus minus A upon under root A square plus B square plus C square. M is equal to plus minus B upon under root A square plus B square plus C square. Okay, and then we have N. N is nothing but plus minus C upon the square root of A square plus B square plus C square. A square plus B square plus C square. So this gives us the relationship between direction ratios and direction cosines. Okay, so if I quickly revise this once again with all the students, suppose A, B and C are the direction ratios of a line, L, M, and N are the direction cosines of a line, where L is cos alpha, M is cos beta, and N is cos gamma. Since we have just learned that direction ratios are proportional to direction cosines, that means L upon A is equal to M upon B is equal to N upon C. All these three are equal to some constant K. So I can write L is equal to AK, M is equal to BK, N is equal to CK. From our lectures on vector algebra, we had learned that the sum of the square of the direction cosines are equal to 1. That means L square plus M square plus N square is equal to 1. Put the value of L as AK, M as BK, N as CK. We get this. Solve for K, you get the value of K as this. Put this value of K back in equation star. You get L as this, M as this, and N as this. So if I erase all this and if I can write in a concise form, the relationship between the direction cosines, L, M, N, and the direction ratios A, B, C of a directed line L is given by, so this relationship is given by L is equal to plus minus A upon the square root of A square plus B square plus C square. M is equal to plus minus B upon the square root of A square plus B square plus C square. N is equal to plus minus C upon the square root of A square plus B square plus C square. Okay, so what we have learned is this gives us the relationship between the direction cosines L, M, N and direction ratios A, B, and C. So I hope that all students attending this lecture have understood this particular concept and have no particular doubt. Okay, now let's move forward. Let us now talk about the next concept, which is direction cosines of a line. Passing through 2 points. Direction cosines of a line passing through 2 points. Okay, so let's look at the definition for this. Okay, so we can say that let L, M, N be the direction cosine of the line joining the point P, which is x1, y1, z1, and Q, which is given by the coordinates x2, y2, and z2. Okay, then L will be equal to x2 minus x1 upon pq. M will be equal to y2 minus y1 by pq, and n will be equal to z2 minus z1 by pq, where pq is nothing but the distance between the points p and q. Using the distance formula, what is the distance between the points p and q using the distance formula? Square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this gives us the direction cosines of a line passing through 2 points. So all of us know that L, M and N are the direction cosines of a line. Now suppose this line is passing through 2 points. Point P is given by the coordinates x1, y1, z1. Point Q is given by the coordinates x2, y2, z2. Then my L is equal to x2 minus x1 upon pq. M, which is, so L is cos alpha. L is nothing but cos alpha, if all of you can recall. M is nothing but cos beta, which is y2 minus y1 by pq. N is nothing but cos gamma, which is z2 minus z1 by pq, where pq itself is nothing but the distance between the points p and q, which is the square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. And similarly, guys, let's look at the direction ratios. So our next heading now is direction ratios. Direction ratios of the line joining of the line segment joining the point P with coordinate x1, y1, z1, and the point Q with coordinate x2, y2, z2 are given by. So guys, what are the direction ratios? The direction ratios are nothing but x2 minus x1, y2 minus y1, z2 minus z1, or you can even subtract and you can write x1 minus x2, y1 minus y2, z1 minus z2. So these are the direction ratios of the lines joining the 2 points P and Q. Okay, so revising this again, if I talk about calculating direction ratios of a line segment joining the points P with coordinate x1, y1, z1 and Q with coordinates x2, y2, z2, the direction ratios are given by x2 minus x1, comma y2 minus y1, comma z2 minus z1, or x1 minus x2, comma y1 minus y2, comma z1 minus z2. Both are correct. So hoping students are clear with this. Now guys, let's practice questions on the concepts which we have learned in this lecture. So let's look at practice questions based on direction ratios and direction cosines. Practice questions based on the direction ratios and direction cosines of a directed line L. So let's look at these practice questions. So question 1 for this lecture, if a line makes angles, 90 degrees, 60 degrees and 30 degrees with the positive direction of the x, y and z axes respectively, find its direction cosine. The question asks us to find its direction cosines. So let's read the question again. Suppose there is a line which is making an angle 90, 60 and 30 with the positive direction of the x, y and z axis respectively. We need to find its direction cosine. So what will the direction cosines be? So the direction cosines of the line are given by cos alpha. So I can say L which is equal to cos alpha. So let this be 90. So I can say cos 90. Cos 90 is how much, guys? 0. M is nothing but cos beta. Beta is how much? 60. Cos 60 is how much? Half. And n is equal to cos gamma. Gamma is how much? 30. So cos 30 is √3/2. So we can say that the direction cosines of this line are 0, half, √3/2. So my answer is the direction cosines of this line are 0, half, √3/2. These are the direction cosines of this line. Very simple. Directly apply the formula. What are direction cosines? If a line is making an angle alpha, beta and gamma, so alpha here is nothing but 90, beta is 60 and gamma is 30, because these are the angles made by the line with the x, y and the z axis respectively. So these are my direction angles given to us. These are the direction angles given to us. From the direction angles, how do we find the direction cosines? L is cos alpha, M is cos beta, N is cos gamma. Okay, moving forward to the second question, second practice question. If a line has direction ratios, 2, -1, -2, determine its direction cosines. So all students can recall. So what is given to us? We are given the direction ratios. Now guys, how do I denote direction ratios? A is equal to 2, B is equal to -1, C is equal to -2. What are these? These are nothing but my direction ratios of the line. Now I need to find direction cosines. Recall the relationship between direction cosines and direction ratios. L is nothing but plus minus A upon the square root of A square plus B square plus C square. M is nothing but plus minus B upon the square root of A square plus B square plus C square, and N will be plus minus C upon the square root of a square plus b square plus c square. Now guys, the sign of the direction cosine will exactly be same as the sign of direction ratios. So look at A is positive. A is equal to 2, which is positive. So my L will be plus 2 upon the square root of 2 ka square plus minus 1 ka square plus minus 2 ka square. So this will be plus 2 upon square root of 4 plus 1 plus 4, which is plus 2 upon square root of 9, which is plus 2 by 3. Remember, the sign of the direction cosine will exactly be same as the sign of the direction ratio. So A is positive, L will also be positive. But look at M. M depends on B. But what is B? B is negative. So M will also be negative. So it's going to be minus 1 upon square root of, we just found out guys, a square plus b square plus c square comes out as 9. So minus 1 by 3. Similarly, what will be the sign of N? Look at the sign of C. You can look at C. C is negative. So N will also be negative. So this will be minus 2 upon the square root of a square plus b square plus c is 9, and square root of 9 is nothing but 3. So all students can see that using these formulae, we have calculated the direction ratios. We have calculated the direction cosine from the direction ratios A, B, and C. So hoping that students are clear with this and have no doubts. Okay, so students can write a note here that the sign of the direction cosine, the sign of the direction cosine depends on the sign of, it depends on the sign of the direction ratios. The sign of the direction cosine depends on the sign of the direction ratios. You can see that when the direction ratios are positive, the direction cosines are also positive, and when the direction ratios are negative, direction cosines will also be negative. Okay, so moving forward now to the next question, question 3. Let's solve this question. So find the direction cosine. Find the direction cosine of the line passing through 2 points -2, 4, -5 and 1, 2, 3. So we need to find the direction cosines of a line which is passing through 2 points. So let point P be denoted by the coordinates -2, 4 and -5, and point Q be denoted by the coordinates 1, 2 and 3. Now, how do we find the direction cosine? So recall that direction cosine of the line joining 2 points, direction cosines of a line joining 2 points, -2, 4, -5 and 1, 2, 3. In general, I can say, let me first write the general formula. So direction cosines of a line joining 2 points x1, y1, z1, x2, y2, and z2 is, what are the direction cosines, guys? x2 minus x1. So I can say my L is nothing but x2 minus x1 by pq. M is y2 minus y1 by pq. N is equal to z2 minus z1 by pq. This is what we had learned in the lecture today, that the direction cosines of a line joining 2 points are given by L, M and N, which is x2 minus x1 by pq, y2 minus y1 by pq, and z2 minus z1 by pq respectively. Now guys, first of all, let's find pq. What is my pq? Square root of 1 minus of minus 2, that means 1 plus 2 ka square, plus 2 minus 4 ka square. We are applying the distance formula, plus 3 minus of minus 5 makes it 3 plus 5 ka square. So my PQ comes out as square root of 1 plus 2, 3 ka square, 9. Then we have 4 and then we have 64. So this comes out as square root of 77. Okay, now this is x1, this is y1, this is z1, this is x2, y2 and z2. So what will my L be? x2 minus x1, that means 1 minus of minus 2, 3 upon pq is root 77. M will be y2 minus y1, that means 2 minus 4 minus 2 upon square root of 77, and N will be z2 minus z1, that means 3 minus of minus 5, 8 upon the square root of 77. So these are my direction cosines. These are my direction cosines of the line. So again, we have directly applied the formula which we had learned today, how to find the direction cosines of a line passing through 2 points. So this is the formula and we have directly applied the formula to find the answer. Okay, now let's look at question 4. Find the direction cosines of the x, y and the z axis. Okay, so now guys, if you look at the x, y and z axis, so I can say that the x axis makes angles, the x-axis makes angles 0 degree, 90 degree and 90 degree with respectively, this is a very important word here, respectively with the x, y and the z axis respectively. All of us know this. Okay, we know that x-axis will make an angle of 0 degrees with itself. It will make an angle of 90 degrees with the y-axis, 90 degrees with the z-axis. So what will be the direction cosines? Direction cosines of the x-axis are cos 0, cos 90, which is nothing but 1, 0, 0. So these are the direction cosines. These are the direction cosines of the x-axis. Now, similarly, if you talk about y-axis will make an angle of 90 degrees, 0 and 90 degrees with the x, y and z axis respectively. So I can say that direction cosines of the y-axis are cos 90, cos 0, cos 90, which are 0, 1, 0. And similarly, we can say that direction cosines of the z-axis are, now z-axis will make an angle of 90, 90 and 0 respectively with the x, y and z-axis. So I can say the direction cosines of the z-axis are cos 90, and cos 0, which are nothing but 0, 0, 1. That means direction cosines of the x-axis are 1, 0, 0. Direction cosines of the y-axis are 0, 1, 0. Direction cosines of the z-axis are 0, 0, 1. So hoping all students have understood this question and have no doubt. Moving forward to question 5, which is the last question I intend to do for this lecture. Show that the point A given by 2, 3, minus 4, B given by the points 1, minus 2, 3, and C given by the points 3, 8, minus 11 are collinear. We need to show that these 3 points are collinear. Now, how do I check for collinearity? Okay, so if I use the concept which we have learned today, let us find the direction ratios of, you can check for collinearity using the vectors also. You can find the AB vector, you can find the BC vector, you can find the AC vector, you can find their magnitudes. You will learn that magnitude of one vector will be the sum of the magnitude of the other vector. So you can show that these 3 points are collinear using the vector algebra as well. But since we have learned direction ratios and direction cosines in the lecture today, I will be using this concept to show that A, B and C are collinear. So the direction ratios of the line joining points A and B are, what are the direction ratios of the line joining A and B? 1, minus 2, comma, minus 2, minus 3, comma, 3 minus of minus 4, which means plus 4. So these are minus 1, minus 5 and 7. Direction ratios of the line joining A and B. We have just learned in the lecture today what are the direction ratios of a line joining 2 points. Direction ratios of a line joining 2 points is nothing but x2 minus x1, y2 minus y1, z2 minus z1. In this case, 1 minus 2, minus 2 minus 3, 3 minus of minus 4, which means plus 4. So we get minus 1, minus 5 and 7. Similarly, guys, direction ratios of the line joining the points B and C. What are the direction ratios of the line joining B and C? 3 minus 1, comma 8 minus of minus 2, which makes it plus 2, minus 11 minus 3. So this makes it 2, 10, minus 14. Now clearly, guys, if you compare 1 and 2, or if you compare star with star dash, what do we learn? We learn that the direction ratios of AB and BC are proportional. They are proportional since, you can check it, guys, 2 upon minus 1 is exactly equal to 10 upon minus 5 is exactly equal to minus 14 upon 7. So the direction ratios of AB and BC are proportional. And since they are proportional, therefore AB is parallel to BC. But since B is the common point, now guys, if B is the common point and AB is parallel to BC, what does this mean? It means that A, B and C are lying on the same line. That simply means that they are collinear. It simply means that A, B and C are collinear. So hoping that students have understood this. First, we found out the direction ratios of the line joining A and B. Then we found out the direction ratios of the line joining B and C. We have seen that both these direction ratios are proportional to each other. That means AB is parallel to BC. But since B is the common point, it means A, B and C are lying on the same line. That means they are collinear. Okay, so I hope that all students have enjoyed this lecture. This is where I intend to stop in this particular lecture. What we have covered in this lecture is the concept of direction cosines and direction ratios of a directed line L in the three-dimensional space. Now in the next lecture, I intend to do some questions from exercise 11.1 of NCERT. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or call up or mail me your doubts at divineschooloфeconomics@gmail.com. So this is where I stop in this lecture.